My name is Jeff Gelb. I'm from Scholastic. I'm the head of foundational engineering. And I have teams at Scholastic, some talented folks, some of whom are here in the audience with me, who are working on core identity services, integration services, DevOps engineering, and other sort of foundational components for our Scholastic Technology Services, which is the central technology organization that is doing our best to, there we go, great, to create a unified technology arm and implementation for all of Scholastic. Topic of today's talk is enterprise integration strategy, and well, you'll see. There we go. So this is what you can expect. There's the table of contents, essentially. Tell you a little bit about Scholastic, a little bit about what I mean by enterprise integrations, give you some examples of what we're doing, some detailed, deeper dive on the implementation and the technologies, some lessons learned and our next steps, and a little time for Q&A. And more than just this, that's the subject matter. I'm going to show you, I hope, how integration, particularly self-service integration, an integration platform, can be an enabler for innovation in an enterprise, and how anybody in this room, big or small, can use some of the same techniques that we're using to do the same things for your company. It's not easy, but it's also not hard, it's not impossible. It's not terribly complicated, and it's not terribly expensive. So let's talk about Scholastic. Who is Scholastic? If you are from the US, you were a kid here, have kids here, think you're going to have kids here, or are a teacher, you probably know who we are. We are the largest children's publisher in the world. We have a lot of iconic titles. We have a relationship with a lot of students and a lot of parents. Our mission, and we take this very seriously, and it's very clean and very nice, is to encourage the growth, intellectual growth of children through literacy. And we've been around since 1920, old company. We are operating and published in 165 countries, 45 languages, and above and beyond the books, we're also a leading provider of educational materials, primarily for kindergarten through 8th grade. And you may be wondering why I'm here giving a talk on technology. But the thing is, to do all those things we just talked about, there's a lot that goes on behind the scenes to make that possible, to operate on a global scale. Anybody here who's employed with or dealt with a large company understands that these day and age, you absolutely have to have a technology strategy to make it all work. So we have a lot of content. We publish 600 titles a year. That's a lot of content. It's text, it's images, it's video, it's metadata. We're a non-trivial commerce operation, B to B to C, because we sell to districts and schools and institutions and to children and to parents, leveraging those relationships in ways that you might not expect. And of course, we're a logistics and distribution company as well, and that spans the physical. We have 130,000 of these book fairs a year. You may have seen those. They pop up retail experiences in your school. They are there for a day and then they go away. We have relationships with 70,000 schools in the US, and we also do a lot of digital. That's applications, it's marketing sites, it's mobile games, it's things to support our trade paperbacks, and it's educational applications as well. And that's why we're talking about technology. So, like a lot of companies, like many of you here, I would assume, Scholastic's technology strategy and implementation is in transition. And we're in the midst of a transformation. Amazon Web Services and cloud in general has made dramatic changes to a lot of the underlying assumptions that were sort of instrumental in our prior technology footing. And so a few years ago, we started out on a 3-year goal to transform our entire technology strategy, soup to nuts, top to bottom. No sacred cows, nothing was untouchable. And there were a few themes to that. Externalized commodity services. If it wasn't core to what we were doing for our business and our customers, we wanted to find a partner who was going to help us with that. We wanted to be able to concentrate less on routine operational activities and more on strategic investments and changes. We wanted to make sure that our customers, for me, our customers are our developers and technology teams, but of course our customers are our children, that they had better quality of service. We could deliver things faster to them, whether that was a digital book or it was getting a site out to production sooner. And in general, as an enterprise technology organization, we wanted to make sure that we were functioning as a coordinated system, right? Not one-offs, not silos. And that was a pretty big transformation for us. Probably not unfamiliar to some of you here. We had operated in silos that were aligned along our lines of business. And that was fine, that was great. In fact, it enabled the company to start and thrive. But as we entered this new technology era, that was clearly not going to be up to the task of providing Scholastic what it needed. So before I jump into the specifics of enterprise integration services, I want to call your attention to a few themes that I'm going to cover. You're going to see them come up again and again. These are cross-functional themes that we're trying to do in all of our technology strategy. Self-service. If you are going to use this, whatever capability we're providing, we want you, the consumer, to be able to use it at your pace, not at central technology team's pace. We want to support the product development lifecycle. Whether that's a technology product, software product, a book, it's important that technology is aligned with the business. We want to encourage reuse. Not invented here is not good enough. And it's important that no matter who builds something in the company, that there's at least the opportunity to make it valuable for other folks. And visibility and transparency. If you work in technology, you may have been asked by a manager, I don't understand why this bill is so high, what are you guys doing for me? And we want to make sure that that's something we can always answer. And ideally, that through self-service, it's already obvious. It's about data-driven decisions. And it's one of those things that, as a strategy, helps short-circuit a lot of the politics of technology, which maybe are unavoidable but aren't always helpful. So let's dig in. Integration as a service. Before we really talk about what we mean by that, I need to give you a little context about what we meant by that in the past. If you do any enterprise integrations, you may be familiar with something that looks like what's up here on the board. Well, not in the center, but on the sides. Routing, transformation, transportation, and orchestration. Core integration components, core features of integration. You have lots of applications or a few applications. You want to make sure that when they talk to one another, that's something that you can manage. You can provide levels of service and those things to help integrate the components of your enterprise. At core, really, it's about routing and transformation of data so that you don't have to have each endpoint talking to one another directly and have that be a brittle thing. And that's what we had, and it was good. There were limitations, of course. There are always limitations, but it was fine. It did a great job. It worked because of certain assumptions that were safe to make. Integration patterns were fairly simple. They were channel-based, typically a single consumer. Orchestration was pretty straightforward. There weren't a lot of applications or endpoints talking to one another, so central orchestration was fine. It worked. We could deal with a single protocols, message queue, typically for us. And we only had a single network. To be fair, more than one network, but it was all ours. And administration of all this stuff happened in a central application, and everybody was happy, reasonably happy. At the end, it did us a very good service. It was predictable. We were able to use it to grow the business, and everybody was pretty happy. So you might be asking yourself, and certainly I've been asked, why would we change it all? It's working. What's the point? What's the problem? Well, everything around us is changing. That transformation that I talked about before meant that all of the assumptions that underlied our ability to use that prior integration architecture were no longer true. And as a transformation, as a strategy, we were trying to make them less and less true, faster and faster. New endpoints, new partners, new vendors. We're adopting third-party SaaS providers for services from back-end ERP systems all the way out to e-commerce and hosting. New kinds of data, new integration patterns for that data, new needs to consume that data and manipulate it. And of course, the rate of change was changing. The integral was changing. And it was really important that we had an integration strategy that was capable of enabling that. It certainly needed to not impede it. There we go. So what would that have looked like had we not started off on the thing I'm about to tell you about? Would it look like that had we continued down the path we were going? Nothing wrong with that, but it becomes unwieldy. You can see there's spaghetti there. I didn't do that on purpose solely to make a graphic that looked like spaghetti. That's just what happens when you have lots and lots of endpoints, new applications coming in. Add on top of that half of those might not be in a data center that we can touch. And then another piece of those, maybe 15 nodes today and 2 nodes tomorrow, or go away completely, or that we may need to spin them up in the West Coast or in Singapore. And that database that you see in the upper right might become a web service tomorrow because that's what has to change, or the contract for those services changes. And that centralized enterprise integration pattern becomes very, very unwieldy and difficult, slows the business down. So we asked ourselves the question, why should integration be the constraint? We have integration as a service, infrastructure as a service for going fast for DevOps. We have platform as a service for developers. Why shouldn't we have integration as a service? It didn't seem like it was going to be impossible. So let's talk about what we actually mean by that. It's a platform. It's a self-service platform. People here at Amazon re:Invent are here because you're using Amazon's platforms and leveraging them to do what you want to do. And that's a really powerful pattern, and that's what we want to set out to do. That's what we are doing. Publish features that implement common patterns that are going to be reused, that our customers need and that they're consuming to do what they want to do. Instrumented and monitored so that the people who are operating it and the people who are using it know exactly what's going on and can tell and see how it's behaving for them. And easy to scale, and to scale in multiple dimensions. If I'm going to ask you to trust me to put up a platform that you're going to use to talk and basically make your application happen and talk to its peers and do whatever it needs to do for your piece of the puzzle, you need to know that I'm not going to become the bottleneck. And if I'm going to operate that and provide services, particularly for consumption that's driven by the consumer, that's usable at any time by anybody, that doesn't have to be gated through me, it's really important that I can scale that up and scale that out and shrink it to meet the demands of the enterprise and of our customers. We want this to be integrated into the SDLC processes. We're big into continuous integration, continuous deployment, and that means that we can't predict exactly when things are going to be used. And it's important that all these things are completely testable, both for us, so that we can evolve the platform, and for the people who are using it, so that they can validate that it's doing what they need it to do. So we basically blew this up. It's the same as it was before, but it's different. It's not exactly the same. In the center, we have that purple box, which is the transformation. But we've split some things apart, turned them into their own services. We basically said integration is its own service domain, and we can treat it like one. It's a first-class one. Just like we have customer data and product data, and we have identity and authorization as first-class services, integration is a first-class service as well. We're going to define a public contract. That's the public service boundary. It's going to implement some of the features and methods and integration points for people who are using the platform. We're going to centralize, at least logically, the locations where we're doing the work that the platform does, transformation and orchestration in this case. We're going to peel out some common services that are reused over and over and over again. In this case, logging, auditing, authorization, and SLA kinds of monitoring. We're going to treat the points of ingress and egress, the transports, as a first-class component that will be manipulated by the interfaces that we're publishing for CRUD operations. And we're going to provide and integrate with analytics and metrics as a service so that that's available for anybody who's using the platform. And we're not rebuilding it, and it just as a sort of common contract, you can see what's going on. And by pulling it apart, we can scale each of these components independently. We can iterate them independently. We can bring new things in and out. We can add new services. We can split them and parallelize them. And we can start to provide higher level services and values that enterprise integration in its centralized form typically never did. Governance, a registry, service level management, service level gradations, and really know that we can go and do that to meet the needs of our business as we absorb new changes and we adapt. So I want to talk about 4 things that we're doing today. We're already, so here we go, a little bit of levity. Some cute kittens, in case fish are not your thing. They're not quite as fuzzy. Those fish were 4 different spiny fish. I can't pronounce it, their name, but 4 kittens, there we go. So this, enterprise integration is in a lot of ways the glue of an enterprise, and I wanted to show you that this is more like the WD-40 of the enterprise. It's making things happen very quickly. We're unbinding it, we're unlocking ourselves. And I want to show you 4 different ways, not radically different, but different from one another, where we are doing this and it's providing value to us right today. And they're going to be for our, for audiences, our developers and architects, the global enterprise, analytics and data, and transformation and our ability to absorb change and retire tech debt. So, my variant 1, integration platform. That's the core of what it is that we're talking about. So as I said before, it's the core features of integration: input, output, transform, transport. Those are still there. But we've unified API, ESB, and messaging, and abstracted them. We've given the non-functionals for free: performance, latency guarantees, testability, introspection, all those things that each of the teams that might have been doing this before would have had to build for themselves or go without. They get it as the first moment they come on. There's a catalog of integrations, integration patterns, which, enterprise integration has integration patterns. I was joking with the folks who were producing this that I was going to start out by saying, I'm going to talk to you today about enterprise integration patterns. And then I figured that most of you would have fled to start drinking early. But in this case, we want to make sure that folks who need to do the pub-sub pattern or a message audit pattern have it available, and they don't have to think about how to do it. They can just think about when it's appropriate for them and start using it. Of course, self-service, that's a theme that I'm going to talk about a lot. Very, very important that people don't have to go through me or my team as a central gating authority. We want to make sure that the quality of service is implemented at the platform level, but the ability to adopt is really basically at the whim or the need of whoever's doing it. And as I mentioned before, SDLC support. This is an engineering task. It's an engineering function. We want to make sure that the people who are developing our code and functions are able to take it up and use it as soon as they want to. So, this V1 of our variant 1 here, I want to give you a little bit of statistics or some data. So we started in January of this year. That's when we selected, we said, we think we know how we want to do this. By March, 3 months from the beginning, we had real POC up and running. We had real POC customers. I'm going to talk about one of them just next. And we had 3 teams using it. Ourselves, because we're using this platform to implement our own features. One of our international lines of business, and our core identity platform. By June, 6 months in, we were largely feature complete. We were released for general development use and integration into other development teams' practices. And we had 5 teams using it, including 1 greenfield application and 1 old application. So sort of spanning the breadth of what you might expect in a large organization. And September 1st is when we launched into general use. 9 months from when we started. It's a production release, full SDLC support, test harnesses for our API and ESB integrations, integration into third-party SaaS, all the way to the deepest bowels of our back-end systems, including using this to help a new customer service voice response system go and get integrated into the organization. So pretty interesting. Didn't take a lot of time. Talk later on about the size of the team and how much it costs us to run. But we started seeing this basically almost immediately start to unblock the organization, which is what we were hoping would happen. All right, variant 2. Our international line of business who wanted to transform, they were participating in the overall technology transformation, and they wanted to evaluate a new ERP system. These folks are based out of India. Mostly this line of business is serving Asia-Pac Rim, not exclusively that. And they're pretty far away from New York, which is where the central office is located. So they wanted to evaluate this. We, from the Central Technology Organization, wanted to get some information about how it was working because we wanted to potentially adopt it ourselves. So why was this important for them? They were able to move at their own pace. The person who was the lead on that project shot me an instant message one evening. By the end of the next day, they were up and running with access to the platform. And within a week or two, they were doing their own POCs, and they were basically off and running. And that was great. In the past, they might not have even wanted to talk to anybody in Central Technology because they were afraid, legitimately so, that it might be a month or two of us just discussing how we would give them service, and then only to find out that it might not work for them because it was a 14,000-mile backhaul for each one of their calls. So this enabled them to participate in the enterprise in a way that they wouldn't have done before. It enabled us to see and participate in their work and reuse some of the work and effort that they were doing. One of the reasons that they were willing to come on board was because they knew with our technology strategy and our use of Amazon Web Services that there were not going to be any scale-out concerns. That if they needed a point of presence in Singapore or in India, that it was going to be possible for us to give them something closer to where they were. Worst case scenario, if it turned out that our central team that was managing the platform wasn't really capable of meeting their requirements, they knew that they could fork it and do it themselves using the same base that we had. And that's not what we wanted to have happened, but it's a really nice assurance as a consumer to know that you're not going to be stranded. And that generally speaking, the footing that you get started with is going to be largely capable of meeting whatever need you might have. And all told, that gave them the freedom to innovate in a way that they wouldn't have had before. So variant 3, data and business information transformation. I've talked about what we did as a core platform. I've talked about how we served our international customers. This is how we started using this almost immediately to fast track our enterprise data warehouse transformation and migration. We have a 20 terabyte data warehouse with data that's been around 15 years of data in it. 20 terabytes is not gigantic by those metrics, but it's not a small thing. And we wanted to move it, ideally in a year, while live, from its existing implementation in a traditional data warehouse to Amazon's ecosystem. And this is a historically very slow-moving world. It's real data, runs the business, high risk, high stakes, and it's been challenging, and people are very risk averse when it comes to this, and that's not unreasonable. So how long do you think it might take to go and get started unwinding and migrating live enterprise data warehouse? For us, it's happening right now, but it was about 2 weeks from when the project was kicked off to when they were peeling off their first parallel feed from the existing bus, using the existing mappings and data transformations to get the data and start to analyze what it did, and using Amazon data pipelines and Lambda to go and actually do live transformation of data and feeding the bus. It took longer to decide to do the work than it did to start doing the work. And all because the platform that we provided with the self-service capabilities and the ability to feed and hook into the existing ecosystem basically unblocked it, turned the how are we going to do this question into a when do we get started question. And just so you know, and Christian, you're going to enjoy this, this here is an example of bridging some of the oldest operating technology one might imagine, an AS400, all the way into Amazon's Redshift and the live ecosystem. So we are using this to bridge, the broadest continuum or edges of the spectrum of data that exists in the enterprise. And it really, again, has not been a problem. It's more of a challenge to understand what the transformations are doing than it is to actually move the data around. And we're also using this to facilitate our architectural transformation for our data as a general. We're moving towards a domain-driven data architecture, and having this available allows us to facilitate that and start to, particularly grabbing a parallel feed from the bus. And then one last one, similar in some ways, integration forensics. Our existing technology has been around for 15 years, largely in its similar state. And there's a lot that's going on there, and institutional knowledge, as our company has changed and people have come and gone, there's a lot of lost institutional knowledge. People were very afraid to touch it, in part because it was difficult to understand what was going on, and in part because there wasn't really an opportunity to make a change even if we understood exactly what was happening. So we leveraged the same patterns that we did before, grabbed a parallel feed off of the existing bus, a wiretap essentially, no need to disrupt anything. And we started feeding that through our monitoring and instrumentation using Elasticsearch, Sumo Logic, Redshift, and other tools so that we could start to understand in real time exactly what was going on the bus, start to refactor things, and be able to guarantee that we weren't going to break anything. And then when we were comfortable that we had exactly what we needed or that we had introduced the amount of change we needed to introduce, we could cut over on a per endpoint basis or a per integration basis or a per message basis if we wanted to, by basically deciding where and when the data that was flowing over our now integrated buses left one or the other. And we use this, very immediately we're using this to also introduce test-driven development into integrations in a place that we couldn't do before. One of the things that we're also doing as a company is moving our e-commerce platform from in-house, not proprietary, off-the-shelf software, but that was operated in-house to a third-party SaaS. And that's a pretty big change in assumptions. And we were able, using this, to introduce basically a wiretap or an audit when the messages were being produced by both our old systems and our new system, and then feed it through the transformation, grab a copy at various points in the transform, including at the very, very end, and be able to do comparisons of the old transport or the old path and the new path to guarantee that the data was exactly the same, and then put that into automated test suites. And it was turned what was a manual 1 or 2 week long and very, very point-driven testing process into an automated one that we could run at will. So very, very powerful. We think that we're going to, we know that we're going to be using this heavily. All right, so let's talk implementation. It doesn't look exactly like this, but it looks a little bit more like this than I would like. A little context again. Where were we? What we had. It was a mature commercial product. We had a very well-defined business object dictionary, taxonomy of our data, and we were using pub/sub as a pattern. That's pretty good. That's what you want to be. And what was not as good? Well, we had a mature commercial product. It had been around for 10 years. We had not necessarily kept up with the times, and a lot of the design assumptions that were built into it, whether we had kept up or not, were 10-year-old assumptions. Whether it was perfect and we were great at it, the world had changed out underneath it. Didn't really have very good support for our developers. Could take weeks to get service done. Single topic, single topology. That's maybe on us more than it was on the architecture. Single data center, well, then you can start to get into the consequences of having a centralized infrastructure. A little difficult without some complexity to go and get an enterprise integration, central enterprise integration bus running globally. Single environment, testing was tough. We had a lot of folks who said, oh, I can test my application really well, but I can't test what's going on the bus. And that was an impediment to development and also led to some nasty surprises when folks were getting ready to release. And a single team. This is an interesting one. A team is a fine team. They know their domain really well. They did a good job, and it wasn't enough. At some point, the team becomes the bottleneck. And as an enterprise strategy and technology strategy, you need to build something that going to take that off the table as the constraint. Why should integrations be the constraint? So let's talk about how we're doing this. Part of the reason that this is possible for us is because we are leveraging a lot of the technologies and investments that we were already making in our cloud transformation. When I did the initial draft of this talk, I was going to talk a lot about our DevOps transformation and our cloud migrations. There wasn't enough time to talk about all of that. I have some team members here, Adam and Todd and Felipe, who have been really instrumental in getting that off the ground, and I encourage you to talk to them. I think we have an interesting story to tell about how we've done our cloud migrations as well. But we took advantage of the exact same things we had already done for all of our commodity infrastructure: Amazon Web Services and platforms and third-party SaaS. We leveraged our automation, our configuration automation, AMIs and Packer, CloudFront, Chef, consoles now getting into the mix. We decided on open source integration framework, WSO2. It has an API manager and an ESB. Those two components were the ones that we wanted to adopt. It's fine. It's an Apache project. It has limitations, but it's great. Does a really good job for what we wanted. We took advantage of multiple transports, including some open source ones, Kafka and Rabbit. People who do this stuff will have seen those. And we also leveraged, of course, our existing bus. And then a service-oriented architecture. Everything we were going to do was going to be built out as an API, or really as a service with an API, and we were going to build stuff that way, and we were going to consume things that way. Okay. So here are the broad pieces of where we are now. And this is mostly a logical diagram, except at the bottom where I talked about analytics, where I got so excited I had to put in some specifics. WSO2 API Manager, API Gateway, Kafka and Rabbit MQ. And I should have put in our existing bus as well, our transport. That's our transport tier. We have kind of the interface functions tier. I talked about this a little bit before. Basically, publish, subscribe, create, delete, all the tools that a developer or an operations person uses to manipulate the system. That's our service boundary. We have the WSO2 ESB, which is handling transformation and orchestration. And we have common platform services also built into the API manager and leveraging Kafka and RabbitMQ to do their heavy lifting for logging, for auditing, for authorization tied into our corporate identity systems, our customer-facing corporate identity systems, and SLA monitoring of various kinds so we can tell exactly what's happening. And then to implement a lot of the analytics, we are feeding it via Kafka into Storm for distribution and transformation for streaming data into a number of different analytics options, using Redshift, using Influx and Grafana, using Elasticsearch and Kibana. And basically, part of the reason that there's as much in there as there is because we're not sure exactly what we need, but we were able to leverage this architecture and infrastructure to feed it many of these things in parallel so that we can extract the value that we wanted, and we knew that we could change that whenever we wanted to. And in fact, one of the things that we've already done, when we started out, we implemented our own Elasticsearch cluster, and that was fine. We actually implemented our own Influx and Grafana cluster as well, and within a month or so, we had swapped out to a SaaS provider for Influx, and we were betaing Amazon's Elasticsearch as a service and are going to be using that going forward because we weren't really interested in running our own infrastructure, but we needed to do that to get started. And just also as a technology thing, those interfaces that we're talking about, those are actually written in Scala and Akka, running on the JVM. So they're pretty flexible, pretty nice developer experience, and very nice performance as well. So for developer, what does this look like? Well, it looks like a lot of other development things. That was part of the point. You describe your APIs using Swagger. That's an emerging or really open standard for API description. You commit it in your source code repository. We're using Git. And you basically commit or branch and do a pull request and feed it into whatever your branch is. Jenkins continuous integration goes and picks that up, deploys via those services that we were talking about, the interfaces, and then your API and your services are available and all registered and getting all that goodness we talked about. ESB orchestrations are not quite as nice or maybe not quite as simple. They're not quite as config-driven, but we were able to wire into Jenkins a deployment mechanism that deploys right into our non-production instance of the WSO2 ecosystem. And from the developer perspective, for the most part, you're writing an application. When you've decided that it's time to do a build, it gets built and tested. All this is going into a non-production integration instance. So we have for our SDLC, we've got a dev and a pre-release for the platform itself, and then we have integration and production, and maybe we're going to performance. We haven't decided yet, which is really more for the consumers to be able to model their stuff without risking anything production. So when you think, as the person who's developing, that your stuff is ready, you use the exact same process to publish into production with some more gates and governance. It's not that it's willy-nilly, but there's not really anything mechanically different about what you have to do. And there are, of course, because of the service interfaces, we're able to write integration tests that test the integrations themselves along with all the other code. And because of the logging and auditing services, you can see exactly what's going on from a debugging perspective, from a performance perspective. And we are, from that perspective, for a developer, we have log.io and logstash for log aggregation that allows sort of the more technical logs to be visible and searchable and all those things that when you're developing a service you might use so that you can understand what's happening or really why something is going wrong. So for data and applications, what's the flow look like here? Well, those platform interfaces are off the table. They exist, but it's not really what's used here. All those applications on the side, they feed their data into the transport, whether it's an HTTP-based REST call, or it's a Kafka topic, or it's writing to a queue. That rolls into our transport tier, and as part of that publication process that we talked about before with those service interfaces, that does the wiring and the routing into our transformation and orchestration tier. And you are reading data from those or writing data from those. Depending on what's actually implemented, that can be a direct call to a database on the back end for some of our older stuff. But most of our newer stuff is just expecting to read an event off of the event bus. We're pretty bullish on Kafka and sort of the event-driven pub/sub patterns as a general integration pattern. You see here that transformation, that purple box for transformation orchestration, we've actually started to evolve it already. We're not just using WSO2. We're starting to write some of our transforms and orchestrations in Scala and Akka as well. And I'll get into the why in a little bit. And then all those things are feeding data through those platform services into our analytics engine. And this is now more for operational metrics about what's going on. So you can see how many messages per unit time are flowing from e-commerce ingress point to the backend system. And then you can do searches and other kinds of things so you can get into the details of that without having to go write a custom query, without having to talk to the database directly. And really, that becomes a first-class citizen that can also drive some business intelligence back into the system from what otherwise would be either completely opaque information or very technical metrics. And for this also, we're dogfooding it ourselves. All the data that we're using is being written on a Kafka, sent over Kafka, being sent on topics, and being consumed that way. Very, very loose coupling from an actual integration perspective. And then for operations, now this is, it's going to seem a little repetitive, and that's because it is, because we're reusing the same patterns. All of the things that happen, every event, whether it's an API call, it's an authorization or authentication, it's an OAuth call, it's a message being written, it's a publish or subscribe or creation, manipulation of the services, or it's the logging stuff, is all being fed into our analytics engine here. And I mentioned the details there before. It's very flexible. We are evolving it as rapidly as we care to and as rapidly as we want to. And the moment we see that there is anything that's bringing value to the table, we're starting to swap that out. The announcement this morning about Amazon's new business BI tooling, very exciting for us because it's going to save us a lot of hassle and grief for doing nice visualizations of what's going on. And as a technologist, it's always the hardest to visualize and demonstrate to non-technical people exactly what's going on. But a picture is worth 1,000 words. Maybe this picture is worth 200 words, but still. And all those services, in turn, of course, can be reading and writing and aggregating and decomposing and reorchestrating the data as they feed it in and feed stuff back into the system. And it's just very straightforward. Complicated, but straightforward. All right, so here's the complete picture. This one is the most detailed, and this is not a tech talk, not exactly. But this is really what the platform looks like. WSO2 identity server, WSO2 API manager, the WSO2 ESB. Those are the WSO2 components. We have a Kafka cluster that has some workers that's being used for our event transport. I'm not actually showing the Rabbit MQ or our other message queue system, but they're there. We have a message auditing service that's where we're feeding the data for audits. We have a log aggregation service that's going and acting as an aggregation point and feeding the streaming. We have an SDLC API, or basically the service management service. And the analytics platform looks like what it looks like. So this here, just any guess from anybody how much you think it might cost us to run this? It's the end of the day. We can be informal. Anybody? No? OK. So this is about 20 EC2 instances, all told, for us. They're primarily T2 mediums, I think. And it costs us about a little under $1,000 a month to operate. And half of those servers and services are ones that we're only running ourselves right now because there weren't software as a service or platforms available for us, or because our broader enterprise strategy for analytics, for example, is a little behind where this platform is. So we're bootstrapping by running some things ourselves. So of that $1,000, fully half of it's going to go away as soon as the rest of our organization and technology transformation is caught up. That's $500. And that's without reserved instances whatsoever. So let's make that $500, $300. So $300 a month to run this. And that $300 a month to run this is without auto scale. We haven't really tried to really tune it. Our small clusters for the API management and for our ESB, 3 T2 medium instances, just naive, barely tuned, are capable of 420 transactions per second of our typical messaging infrastructure, typical message sizes. And so that's 36 million a day, something like that. And that seemed like plenty. And they're all scalable. Those services are generally speaking stateless, so they're completely open to horizontal scale. We really didn't have to worry about that whatsoever. And we suspect with tuning them and with ESB in many ways is the heaviest piece, so we suspect strongly that if we replace the ESB with the Scala and Akka services, that we're going to be able to scale that, well, not infinitely, but dramatically. So, and this was put together, a team of 5, 2 hardcore integrations developers who had done this, something like this before, 2 offshore folks, very skilled, who primarily were Ruby on Rails developers before they started doing this work, and a DevOps engineer who was not doing this as his full-time job. So small team, 5 people, 9 months to go from what I showed you before, basically nothing, to this, with all those features and the integration points into the organization. Really not that bad. I said before that anybody could do this, and I really think it's true. It's not a huge investment of time, not a huge investment of money, and not a really big risk. We can absorb as much risk as we want to, or stall and slow down if we need to. And we can basically control the rate of change to our heart's content. All right, so I want to thank you for sticking with me. We'll talk some lessons learned, and then we're going to take some questions. And I had a picture, which I couldn't find the rights, so I didn't put it up there, of a cat that had worked its way into a bottle for our lessons learned, but I had to do the one that was public domain. Give me a moment, and then I'll take it. So where we are now, right? I'll do the same format as before. What's good, what's not as good. So now we have really good SDLC support, dramatically better than it was before. We have instrumentation that is nothing like we had before, unprecedented, at least for us. Best of breed in a lot of ways, and the ability to continue to make that best of breed in as much as we're capable of dealing with it. We have a topology that's completely flexible, both in terms of where it's deployed and each of those subcomponents, how they're deployed, and the ability to roll stuff in or out depending on need. The transports are flexible. You already see we're doing 2 or 3 different ones. We can support multiple environments. We can support a dev environment, a QA environment, a perf environment. We can support a dedicated environment for you in case that's what you need to meet whatever your needs are. And for us, because we deal with children, sometimes it's a regulatory requirement that privacy boundaries are established and maintained. We know that we can flex this to meet those needs no matter what. We're operating in multiple data centers and multiple instances. Those things are things we can do. There aren't things that we're not doing them just yet. There are some things that aren't that great. The developer experience for people who are developing the integrations themselves. So not the dev experience for somebody who needs to use an integration, but if you need to actually write an orchestration, WSO2, it's great for what it is. It's just not super polished. If you pick up one of the better commercial software out there, it's a nicer developer experience. The automation for the platform, it's pretty good for what it is, but it's not as good as it needs to be. We're finding it's holding us back a little bit. We're digging away at that and digging away at that, but we're also hopeful that we're going to take some of those things off the table. And then complexity. I mean, you saw that picture before. There are a lot of components, and before there were just a few components. And I need to be recognized. We need to own up that complexity, but in and of itself, is a detriment unless it adds sufficient value. But in general, for the set of integration requirements that we have now and that we anticipate having, as more and more of our organization changes, this is just a much better fit for purpose. Some lessons learned. This is not really about integrations. This is just about us and our journey. We would have done ourselves a good service if we had known when to cut our losses on certain things. It's hard, especially when you get into the details. Say, oh, if I know I just change this right now, I'll be able to get it to work. Yeah, no problem. And suddenly 2 sprints have gone by. It's a month. You're not released yet. If we, looking back, there are certain avenues we took where if we had just sucked it up and stopped, we would have been better off. So be it. We need to be flexible, and the cultural thing about being flexible is harder than the actual technology part at this point. Self-service is not enough. We built it, and only a few people came. Now, they had an interest. We found, maybe that's just for us, but I suspect a lot of the people here are going to find the same thing, that you need onboarding, you need developer support, you need an SDK, you need examples. You don't need necessarily to hold somebody's hand, but you need to have the outstretched arm at least. And then the developer workflow and the testing workflow, harder than it seemed. We're still working on that. The solace in that is that even the limited bits we have now are better than they were. But managing distributed but centralized integrations as a service through their lifecycle requires careful thought in and of itself. When it was centralized through a single team and a single infrastructure, you had no choice but to deal with that. And most of the strategy for dealing with that was simply by not allowing a lot of change. Now we have a world in which change can be introduced all the time by design. We need to have some sort of governance to balance that out. Completely parallel to cloud infrastructure as a service, you unlock the gates and unleash the people, and suddenly you get sprawl. It's what you want, but by itself it can also be a drag. And then our next steps, we're going to get rid of that ESB. I previewed that before. Ultimately, what we found is that at the end, you always end up doing development. Integration development is still development. An integration server is just a very specialized container. And if we're going to go do that, why not just own it and use tools that have a better developer experience? The ESB is pretty heavy for what it does. ESB as a pattern is kind of old already. And again, you can be the best one, and I'm sure that there are great ones out there. I'm not trying to say that I'm an expert here. But broadly speaking for us, it's kind of slow, it's kind of heavy, it's hard to distribute, it's hard to manage. We think that by exploiting infrastructure as a service and all these other things that I showed you, that we can do a much better job, much lighter, and have something that's going to be much more flexible. And of course, we can always swap one back in if we need to, because the architecture I laid out there doesn't really impose any particular transport mechanism, or well, if we want to run parallel forever, we could. Wrapping up here, I want to give some thanks to my management. Scholastic is an interesting company, old school children's publisher, some very progressive management right now who's giving us a lot of support to do these kinds of things. Mark Bonanno and the integration services team, it's the developers, Adam Jaffe and the cloud transformation engineers. Without those folks, this would not have been possible. And I'm only talking here because I'm taking advantage of the spectacular work and dedication that they put in. So thank you. We're hiring, by the way, if any of this is interesting and you like Soho in New York City, we would love to talk to you more about this world. We have a lot of other stuff going on.